Hello, welcome back. So today I want to, let me just get back where we were. So this is where we were. I've been a bit slow with the, recaps, but actually today I'm a little bit in the mood to do something completely different. So I've mentioned this before. So far everything we've done is we've been looking at metagenomes, actually through the GMGC, just looking at and now what we're going to do is going to look at genomes. So as I said, I mentioned before that so this idea of what co-occurs together can be operationalized in these two different ways, at least. And so far we've looked at metagenomes, and now let's start looking at and so for that I am going to look at progenomes. And actually I am not as familiar with progenomes v3 as I was with progenomes v2, where I was also involved with so here I am. So for those who don't know, so what's progenomes? Progenomes is, for example, let me see. Okay, this is not working. That's not how you spell Vibrio Fisher. Is it Ali Vibrio Fisher right now? Okay, hard to keep up with all the name changes, but I get. Right. So what's progenome? So progenomes is a collection of genomes. So here, for example, and they are organized using they're genomically classified in that sense. Very similar to what the GTDB also does. I guess the GTDB is very well known. But then the other thing that's nice is they've been pre-processed. So here, so there's a just under 1 million, so 915,000 genomes. So this was and so there's species clusters. So this is genomic definition of species. So this is based on these marker genes, and it goes back now to Daniel Mendes' paper from 2013. So this is now a classic paper. And it's Alu Vibrio Fischeri. I thought formerly Vibrio Fischeri. Okay. Okay, and so the nice thing about progenome is that you have you have the genomes, and then they've been grouped in genomically, so that and then you have gene calls. So these are the marker genes, belongs to this PECI cluster, and then here's the sequences. And they have antibiotic resistant genes already called. So in this case, using megares through abricate and deep ARG. Okay. So unfortunately, not RGI. Okay, also gecko, which is biosynthetic gene clusters. And let's see that. So we could get the contigs here. Just see. Get the good. Hooray, we got the contig. Alright, this is not. Okay, so we could get the representative. So the spec eyes, or the gene clusters. So there's a representative genome from each spec eye cluster. So which is what we will be calling species. So this is spec eye. This is one of the most unfortunate things about this name is that I'm always tempted to read it as speckle with the L at the end, but that's a capital I. Let's see, what does this habitats table have? Okay, that's 100. Okay. Oh, this is incorrect. By the way, the citation at the bottom is incorrect. I will email them, but yeah. So this should be the citation at the bottom. Should be this one. Oh, actually, no. Also not this one. The citation should be this one, which is, this is already 2023. I'm trying to understand. So this file here gave us the annotations, but not. So what I would want to do is I want to download the genomes, but not just the representatives. So for example, let's pick this one. Let's do the Ali Vibrio. So what I'm hoping is that there's a way to download everything, maybe with a tiny amount of scripting, but hopefully nothing too Okay. So if we have this identifier, then that works. What is marker genes? Spec high clustering data. Is this what we want? Okay, this might work. All right, this might work. So here, spec high clustering data. So we might have. Let's just check this real quick. Okay, I'm gonna create a new directory. Get progenomes 3 and okay. All right. So I've been on another project. I've been writing a lot of this code. Actually, on the Argnon project, we've been writing a lot of this code. So this is why this was absolutely just sort of typed off. So this is. So just yeah. So this is a jug code. So it's a. Oops, sorry. So it's jug code. So this kind of looks like Python, or it is Python, but we're using this framework where we say this is it's now a task generator. So this is a function, and when we call the function, it creates a task to execute the function, right? And then we run it not with Python but with jug, and then let's see now. No, I don't want to do that. Oh. Okay, let's actually not do this like this. Let's do it like this. Okay, why is this taking so long? Okay, so something is, so OBS is the streaming software, and then something is making new Vim. Okay, so I just killed it and restarted it. Okay, let's. Okay. Okay. It's probably E. coli or something. Okay, so that, yeah, Copilot was excellent at this. So I had written the code and I just wanted to adapt it to a function, and Copilot basically can be trusted to do that. Yeah. So now let's just execute with Chug. So this is one of the, so this is one of the things that you learn a little bit if you use Copilot for. It doesn't take that long, but you start to learn very quickly what kind of tasks it excels at and what kind of tasks you really can't trust it. So, right. So now what do I want? Now I want to download. Okay, so I wanna do something like this. Yeah, this actually seems pretty reasonable, except the URL is wrong. So the URL probably is work? No. Missing taxonomy in project. Okay. Not sure that this is going to work, to be honest. Alright, so here, by the way, so you can see, so there's our get progenomes.py, and then this ends up getting associated with the jug data. So this is a magical directory. We're not going to be looking into it too much, but it has them. All of these files ensure that things kind of work. Actually, let me just see that. Yeah. Nice. Okay, I'm actually going to rename this from get progenomes by to just progenomes 3, because I might want to add a little bit more information later. So one of the effects is that this, because now we've renamed things, so everything would get renamed. So now, you know, previously there was a task that was called get progenomes 3.download clustering table. Now that task is called progenomes 3 download clustering table, and so and Jug's not not particularly smart, so it only identifies tasks by their name. So because the name changed, now it thinks it has to do them again. So now when we run it, when we run it, first of all, let's run the right thing. It's going to, it's going to run the download the clustering table task. So we're repeating a little bit of the work we did before. So downloading that, and now, yeah. So now it's just downloading the data. So this is going to take a while, and actually probably this time I am going to run it off stream. So because this is probably, yeah, this might take an hour or two to run, so I'm going to be running this off stream. But I think this is pretty good. So I'm actually going to go back to the main, and I am going to commit this. Yeah, so we are going to ignore, so we're already ignoring any directories with that are called data. We're also going to ignore any directories that are called .check data. We are also ignoring PyCache, and here we are going to specifically ignore the directory source subplots. So if I now go back to the source progenomes, yeah, so now, yeah, you can see Git is now ignoring this one. It was already ignoring this one, and so resources, or where do we put this? Oh yeah, I think this one we did. So okay, and this is what we're doing today, analyzing the isolate genomes. So this is also part. We haven't really finished the other side of the project, but today I somehow felt I wanted something new, and so let's look at this. And put here progenomes. And so a spec-i cluster is going to be so a spec-i cluster is going to be our definition of species. So when we say two genomes are in the same species, that will be code for two genomes are in the same spec-i cluster. I mean, yeah, we could have used a different definition. We could have used the GTDB. But partly because things are also already kind of organized for us by the spec-i by the progenomes, we are going to be using it. Forgot to add this. Okay, so this is going to take a while to run. Oh, I was I surprised I'm in the wrong. So I was in the wrong environment, but it doesn't matter. So this is going to take a while to run. So what I'm going to do is I'm going to kind of cheat, just for the purposes of now. Okay, all right, so somehow this came out to that number. Okay. Yeah. Okay, so we apparently had forgotten to install requests. So let's just install requests quickly. So request is a Python library that will help us download, to download things. It's actually fairly it's a bit like NumPy and those kind of things. It's not part of the standard official Python standard library, but it it maybe should be, because it's so widely used, and so it's very robust, etc. So okay. All right, so let's do this. Actually, I'm going to be even more. I just need a few, so let's. Last requests here. Okay, sorry, I messed that up. I didn't. I'm gonna add this to them. Okay. Yeah. So now this is going very fast, because yeah. So this so I guessed, and I guessed apparently correctly, that the early spec I, so spec I 0 and were the very large ones. So this is actually. And then the later ones, so the ones at the end, are very small. So the ones at the end, and because here we're downloading by SpecI, the ones at the end only have one genome. So now, for example, I'm actually not sure this is going to work. Just quickly check. Might be a bit of a pain. Oh, nice. Nobody expected that. Actually, I think this is not going to work, because I think RGI wants its RGI does not like recent versions of Python sometimes, and so this is 3.11, and RGI I think is going to complain about that. Yep, just for okay, so I'm going to try Conda instead of Mamba, which is probably going to run for a long time and then do nothing. But now, okay, there's an alternative solution for this problem, which is to create a separate environment just for RGI. And so that will work. Okay, let's do the separate environment for RGI approach. I'm gonna do a different. Alright, so I'm here in a different window, Mamba create, and I'm gonna call it RGI, and I'm gonna say it wants RGI. Maybe, yeah. Okay, I'm gonna kill this one. Let's do it now, one at a time. I think they don't like it with if you try to run multiple instances of conda at the same time. It's not very. I mean the locks, so it has locks, and the locks are not very granular. So. Okay, so this is running. Okay, great. Okay. Okay. Okay, so I'm going to run RGI. Let's run it on this guy. It's not this simple. All right, yeah. So type is config. Let's do diamond. Number of threads, let's do 8. Include loose, let's include loose. Clean, yes. So clean is basically we don't want to keep all of the intermediate files around. Keep debug, low quality. I don't think this. Let's do periodical just because. And I'm not sure that these are compatible options. But let's do this. All right, let's maybe not do periodical. Yep. So if you don't know periodical, so periodical, and again, we're looking at Martin's project. As I said, nothing but praise for Martin. And yeah, so periodical is so I can hear he's advertising it as a Python interface to Prodigal, but in the meanwhile, he's actually made a lot more. He's made several improvements to Prodigal. So it's based on Prodigal. It computes the Prodigal functions, but it's a little bit faster. It's a little bit and so you get the same results, but actually better and with a nicer interface and etc. Unfortunately, there are some version changes. I actually recognize this error. So there's some. But other than that, the code is actually quite nice. All right, so. Okay, all right, so this was a bit, so apparently out is just, shouldn't have .txt, so runs, takes a bit. Okay, so here this is an issue of doing this with streaming, is that so OBS, which is the streaming software, will always be running and making everything a little bit slower than it would be. But this was actually not so bad. So let's do this. Let's take this. No, I don't want it. Yeah, there. Okay, so I'm gonna so RGI main. So I'm just gonna Oh, okay, now we have this problem. We have to okay, so okay, so now we have this problem because we have coargs, which is our main working environment, and then we have the RGI environment where we run RGI. So we need to add IPython. To enable jug shell. Okay, so we have this, and so okay, so if I do this, this is just a task generator. But if I call it f.f, that's the actual function, which for some reason, oh yeah, I see what's yeah, so it would call this, and unfortunately this now we have this problem, which is this is the right thing to call, but there's no RGI because we're in the wrong conda environment. So one way around this is to use conda run. I think this is how we call it. Yeah. Oh, no. So conda run, and then the name in the environment called RGI, and then run RGI. This one. Okay. Okay, this will, all right, so, okay, so you can see, so there's, and let's just try running. So I can just, and then let's just see what's, all right, so RGI is running in the background. Now it's calling prodigal. Now there's calling make plus db, right? So it is running in the background. Yeah. So maybe these ones were the ones we called on the command line ourselves directly. Not sure. It's a bit difficult to know, actually, to be honest. Diamond was there briefly. Okay, so this is actually running. I just check the status once again, one last time. Oh, and it has run RGI a couple of times. So yeah. All right, so this is running. Okay, so Okay, so this is done. Okay, so in this case, all right, so you can see that this is going to be, so we ran this a little bit out of order. So I kind of cheated and ran the, ran the the final few first, but we could, we can that, and so it's going to take a while to download all the genomes for all 40,000, and then it's going to take a while longer to run RGI for all of them. So having said that, I mean, it's going to take a while. It's going to use a bunch of disk space, but I think, and I'll run this just on my laptop. This could be done faster on the compute cluster because I could run more things in parallel, but I wanted to keep this to reasonable computational resource usage, and so I think this takes a while, but a while that's reasonable. So maybe I'll leave it running. Maybe I'll even leave it running. So I'm home right now and I'm going to go into the office. Maybe I'll just leave it running on the desk here. Hopefully by the time I'm back, it will have made significant progress, but I won't be running, it on the cluster. Right, okay, so with that, for all downloaded genomes. So now this code is good. So this code I'm going to just push directly to main, instead of leaving it in the log. So yeah, so today we did a little bit of a detour in our path. So this was always in the plan that we would look at progenomes 3. Today, I decided I wanted to start on that today. So we also looked at Chug, and now as I said, I will leave this running and I will see you soon. So let me stop.